So hello, good morning. We are going to start vertical motion. So first question, a body falls from 80 meters. Its time of descent is, and we have to take g equals to 10 meter per second square. So so we have to calculate time of descent when body will fall. Suppose here that is the body, okay, and it falls from the 80 meters. So suppose this is our ground, in the ground little grass is also there, okay. So it will fall 80 meters. We have to calculate time of descent. Time of descent means the time of coming downward, okay. So in how much time it will come downward, so we have to calculate that. So which formula we can apply? So 80 meters is what our distance, huh? In other way we can say height, our height. So one formula is there, s equals to ut plus half 80 square, and we have to calculate our time. So distance we can say height, distance equals to 80 plus u. When it will fall means it will fall from the rest only. So initial velocity will be 0 into time plus half into acceleration. If something is falling downward, it falls due to acceleration of gravity, okay. So acceleration due to gravity, that we have to take 10. Acceleration is here our acceleration equals to g, because of the gravity it will fall downward. So our acceleration is g, and g we have to take 10 meter per second square. So g equals to 10, and after that the time square, the time in which it will come, and we have to calculate that time, okay. So now it will be 80 equals to 10 divided by 2, 5 t square. After that 80 divided by 5 equals to t square. T square equals to 5, the 5 and 3, 5, 6. So t square equals to 16, means t equals to square root of 16 equals to 4. So our time is 4 seconds. So when body will fall after 4 seconds, it will come downward. So that is the time of descent. So here it is said option 2 and option 2 4 seconds. So first question is done. Now we will solve question number 2, which is 32. So now question number 2, which is 32. Two bodies whose masses are in ratio 2:1. So suppose here one body of mass m, the other body will be of mass 2m. M divided by 2m, 1:2. So if one have mass m, other will have mass 2m. So their ratio is 2:1, are dropped simultaneously, okay, at two places A and B, where the acceleration due to gravity are gravity A, gravity B. If they reach the ground simultaneously, okay, if they reach the ground simultaneously, means at same time they will be on the ground. The ratio of the heights from which they are dropped. So we have to calculate what is the ratio of the height, okay. So suppose here our mass is small m, here our mass 2m, okay. Here our ground, suppose this is height ha, this is the height, and this, suppose this place is A, this place is B, okay. From the two different places they are dropped, this is HB. We first consider maybe their height will be different, okay. Then we will see whether height comes same or it will come different. So when it will fall here, acceleration due to gravity is GA, here acceleration due to gravity GB. So now calculate, and it is in the question given, if they reach the ground simultaneously, means in the same time they both will come Suppose they both drop and in the same time both will come. So time t is for same for both. Now we take, if I say height a equals to what? Ut plus half at square. U is 0 because when they will be first hand in the hands and they are in the rest, then they will drop, then they will go downward. So in the initial point they will be in the rest. So ut will be 0, then only half at square will be there, and time is same for both, and acceleration is what? Acceleration is GA for one and GB for the second. So here height A, so acceleration will be GA into T square, and height of B will be what? Half, same way, GB into T square. UT plus half AT square. Acceleration is GB. So half GB into T square. Okay. Now calculate, and T is same for both because in the same time both are coming to the ground. So if we take the ratio, what we have to calculate? The ratio of the heights. The ratio of the heights. So ratio of height HA divided by HB, okay, equals to half of GA square, and T is same for both, so we have taken T as T only. Otherwise, if time is different, then we have taken T1 and T2 different times, but they are coming in the same time, so we take same time for both T. So half GB T square. Half cancel, T square cancel. It will become GA by GB. So ratio of heights will be what? If we say what is the ratio, then ratio of HA to HB equals to GA divided by GB. This is the ratio of the height. It depends on gravity. What is the gravity there? So GA by GB. First option is correct. Okay, question is done. Now question number 3, which is 33. A body falls for 5 seconds. So first body will fall for the 5 second. Okay, if body will fall for the 5 second, after that acceleration due to gravity CZ means the condition is like body will fall for 5 seconds. After that we have to assume acceleration of gravity is not there. After, so when acceleration will be not there, then only whatever the final velocity, it will fall with the velocity, no acceleration. Then the distance travel in the next 3 seconds. It means first it will fall for 5 seconds, then we have to assume acceleration due to gravity stops. When acceleration due to gravity stops, then from that time in the 3 second how much distance it will travel. Mean whatever the velocity after the 5 seconds, it will continue with the that velocity. So because no acceleration, we don't have to take acceleration. So after that, from those 5 seconds, after 5 seconds, whatever the velocity, it will travel with the same velocity. So with the this velocity and 3 seconds, then velocity into time 3 seconds will be the distance it will travel. So I will tell you how. Suppose particle is here. First it will fall for the 5 seconds. For time t equals to 5 seconds. From this point, when 5 seconds complete, no G means no acceleration. When no acceleration, ground is suppose here downward. When no acceleration, from that after 5 seconds, no G, then whatever the velocity will be here, it will continue with the same velocity, it will continue with the velocity only. So, and we have to calculate in that after the gravity will be not there, how much distance it will travel in the 3 seconds. So velocity into, suppose 1 second, 2 second and 3 second. In the 3 second, in the these 3 seconds, how much distance it will travel? So distance equals to what? Speed or velocity into time. So speed into time, 3 second will be the distance. So first we have to calculate what will be this velocity. What will be this velocity after the 5 second? So final velocity v equals to what? Initial velocity u plus at, v equals to u plus at. V we have to calculate initial velocity u is 0, acceleration is g into time 5 second. Initial 5 second g is there. So after 5 second, what is the velocity that we have to calculate? So v equals to g, we can take 10 10 into 5. So V equals to 10 into 5. Okay. So now final velocity what? This velocity V equals to U plus AT. Okay. Acceleration for the 5-second acceleration is G. So for the 5-second acceleration equals to G. And how much time? For the 5-second time T equals to 5 seconds. So apply this thing. So V final velocity will be initial velocity. It starts from the rest only because when you drop, so initial velocity 0 plus acceleration is G into time 5. So V equals to 5 into G. We got our velocity 5 into G. After that, it is saying when gravity will be ceases. When gravity will be ceases, means gravity will be stopped at that time. So for the 3 second, how much distance it will travel? So distance after our gravity ceases means stops. So distance equals to speed into time. And what is the speed? Speed equals to what? 5 into G. So speed is G into 5 into time. Time, how much time? 3 seconds it will continue. We have to tell about 3 seconds. So time 3 seconds for this time period, how much distance it will travel? Here how much distance it will travel? So it will be what? 3 into 5, 15 into G. G is 9.8 you take. So 15 into 9 we can calculate. So 9.8 into 15. 147.0. When you calculate this thing, so distance will come 147.0. So this is our option 3. Question number 5 means 35. A body released from the top of a tower of height h takes time capital T seconds to reach the ground. The position of the body at T by 4 seconds each. Okay, we have to calculate at the time T by 4 what will be the position. So suppose released from the top of tower. So wait 1 second. Ah. So consider this is our tower. Okay, this is our tower of height small h, and if it comes from here downward, okay, then it takes total time equals to capital T. When it fall, it take time T by T. So the position of the body at time T by 4. T by 4, suppose T by 4, suppose from here to here, suppose this is the time T by 4. So when the body will be here, okay, after time T by 4, we have to calculate the position. So we can say h equals to height equals to s equals to ut plus half at square. So h equals to ut plus half gt square. G is the gravity. H equals to half ut 0 into t. So it will come half into g and t square. So this t is the time. So h, it is in the multiply 2h by g equals to t square. Hmm? If it falls height h, okay, with the gravity value acceleration due to gravity g, so time will be t. So we can say t equals to square root of h 2h by g, and that is given capital time t. Huh? So it is equals to t equals to square root of 2h by g. This is the time, and we have to calculate in time t by 4 how much it will go. So distance covered in time t by 4. So distance covered in time t by 4 equals to that h, we can say h naught, that height h naught equals to half into g into time t is t by 4 square. So h naught equals to 4 square 6 means g capital T square by 32. 16 into 2, 4 square will be 16, 16 into 2 32. So it will go gt square by 32. This much height it will go. If we compare, if we want to compare this height, then what we can do, h naught by h equals to what? H is what? H naught is g t square divided by 32, and h height h is what? G t square by 2. Huh? gt square, gt square cancel. So it will become what? It will become 2 by 32 equals to 1 by 16. So h naught equals to, h naught by h equals to 1 by 16. Then h naught equals to h by 16. H naught equals to h by 16. So this height is what? This height is h by 16. H by 16. So suppose this height is what? From the uh, what are the options? At h by 16 from the height, from the ground. From the ground, not from the top tower, it will go downward h by 16. So h by 16 from the tower. This, so if it is h by 16 this, then suppose this is x, so we can say h by 16 plus this x distance will be equals to total height h. Huh? This distance plus this x distance, total distance h by 16 plus x equals to h. So this x is what? Then x equals to h minus h by 16, which is equals to 16h minus h equals to, we can take LCM here. So what you will get? 16h minus h by 16 equals to 15 by 16h. So x equals to 15 by 16h. So this is h by 16 and this is what? 15 by 16 of h. So from the ground, how much distance it will cover? The position will be 15 by 16h. This position is what? 15 by 16h. So from the ground 15 by 16h, and from the top, if that option is not there, if the from the top we calculate from the top h by 16. So first option h by 16 from the ground, that is not correct. From the top h by 16, from the ground 15 by 16 of height. So option 3. You understand how it will be calculated? So question number 36. I stay. I store. So question number 36. A stone falls freely under gravity. It covers height h1, h2, h3 in the first 5 seconds, the next 5 seconds, the next 5 seconds. The relation between h1, h2, and h3. So what is going on? Suppose this is our stone. It falls initial 5 seconds. So when it falls freely means initially u equals to 0. When it falls 5 seconds, here some velocity v1 will be there. After that, it again falls 5 seconds. 5 seconds. Here velocity v2 will be there. Continuously in the gravity, and again it falls 5 seconds. Okay, this initial height is h1. This second height is h2, and the third height is h3, and we have to find the relation between h1, h2, and h3. So first condition in the first case is which when it will fall, we can write first case of 5 seconds. Then height h1 equals to initial velocity ut plus half at square ut u 0. So 0 into time 5 seconds, 0 will be there, plus half into acceleration is g into time t 5 square. So h1 equals to, we can say 25 by this what we h1. Now when it first time it will fall 5 seconds, here after 5 seconds velocity v1 will be there. So first we'll calculate velocity v1 equals to u plus at ag into time 5 seconds. V equals to u plus at, u is 0, acceleration g, time 5 seconds. So v1 equals to u0 plus g into 5 means v1 equals to 5g. We got here velocity v1 equals to 5p. Now second case, see the second case. This is the second case. In the second case, initial velocity is v1. Initial velocity v1, height is h2. So in second case, initial velocity u is what, v1, and v1 equals to 5g we calculated. And now calculate height h2. Equals to initial velocity 5g u into t 5 second ut plus half acceleration g half at square, time again 5 second 5 square. So h2 equals to h2 equals to 25g plus 25 by 2 g. Then is equals to, take the LCM here, take 1, 2 and 50, 75 g by 2. Okay, now when again it will fall from v1, it will go, and here velocity will be v2. When third time motion will be there, initial velocity will be v2. So v2 equals to what? V2 equals to initial velocity v1 plus v equals to final velocity equals to what? This is final velocity, this is initial velocity. Final velocity v2 equals to initial velocity v equals to u plus at, acceleration is what? G into time 5 seconds. So v2 will be v1 5g plus g into 5 means 5g 10g. We got v2 also. And this is our h2. We got h2 and this is our h1. Now we calculate h3. So third case, it start falling from here, it will go up to here. It start from here, go up to here. So what is the initial velocity v2? So h3 equals to ut plus half at square, and its initial velocity is v2, and v2 equals to 10g. So 10g into time again 5 second, how much height it will cover h3? This we have to calculate. Okay, ut plus half into acceleration, g into time again 5. So h3 equals to 10 into y 50, 50g plus 5 square 25, 25 again 25 by 2 into g, 25 into 2 by g, so 125. 125 by 2 g equals to h3. Now we got h1 h2 h3. This is our h3. So let's calculate h1 by h2. h1 by h2 is what? h1 25 by 25 g by 2, h2 h2 here 75 g by 2, 2 to cancel, g cancel, 25 1 25, 3 equals to 1 by 3. It says, implies h2 will go that side, it will become h1 equals to h2 by 3. h1 equals to h2 by 3. Now take the relation between h2 and h3. h2 and h3. h2 is what? 75 g by 2. h3 125 g by 2. 2 to cancel, g cancel. 725 3 ja 75. 24 5 ja. So it will come 3 by 5. h3 will go that side. So what will become? h2 equals to, leave it, h2 equals to 3 by 5 of h3. We got two relations, this relation, this relation. h1 equals to h2 by 3. h1 equals to h2 by 3. After that, h2 equals to 3 by 5 h3. So see, in this, when 3 will go this side, so h2 equals to 3 by 5 h3. So h2 equals to 3 by 5 h3. So this fourth option is correct. So let's solve question number 37. Okay, so question number 37 is what? The ratio of time taken by freely falling body to cover first meter and second meter is. So we have to take the ratio of how much time it takes in the first meter and how much time it takes in the second meter. If something is moving, okay, freely falling, this is the first meter, suppose this is the first meter is covered, this is the second meter it is covered. So we have to take ratio of time, how much it take time in the first meter and how much time it take in the second meter. So our acceleration will be equals to g, our u equals to 0. uh, if I say total time taken in the first is t1, and total time to come up to here is T2. Okay. So then time between this only second meter, not first to 0 to 2, not only 2. So this time will be what? This time will be what? T2 minus T1. Uh, T2 minus T1. Second meter T2 minus T1. If from initial to T2 2 meter is covers, okay, and initial first one is t1, so we have to find first 1 meter cover ratio t1 divide by second meter cover this, second meter cover this, t2 minus t1. So we have to find t2 minus t1 ratio, t2 minus t1. So what will be the t1? So first distance cover is 1 meter. So 1 meter, s, apply the formula, s equals to ut plus half at square. 1 meter initial we have to cover 1 meter. U is 0, so 0, so half into acceleration g into time t1 square, we can write in the first 1 meter t1 square. So 2 will go that side, it will become 2. 2 divided by g, 2 divided by g is square root equals to t1. Now if we say what will be the second case, in the second case it is, we have taken full distance from 1 meter to 2 meter, total 2 meter. So total 2 meter cover equals to initial, that time also initial 0, 0 into t 0. So we can write 2s equals to ut is 0. Then we write directly half a is what? Acceleration equals to g, time is what? t2 square, s equals to ut plus half at square, ut is 0, so 2. So 2 will go this side, it will become 4 by g again square root equals to T2. We got T1, we got T2. Now we have to take T1 ratio. What which ratio we have to take? T1 divided by T2 minus T1. You know how we already discussed how T1, T2 minus T1 comes. Total time T2, and only for the second 2 meter T2 minus T1. So T1 equals to so T1 equals to root 2 by G divided by T2 minus T1. So T2 minus T1 is how much? T2, how much to T2 square root of 4 by G minus T1, T1 again root 2 by G. Okay, T1. So what we can do here? Root G everywhere cancel. So we everywhere we can write root 2 by root G. Downward also we can write root 2. Here we can write root 2 by root G. Huh? And here also root G common, so it will become root 4 minus root 2 divided by root G, root root G. Root G, root G cancel. So it will become what? Root 2 divided by root 4 minus root 2. So it will root 4 equals to what? 2. So it will become root 2 divided by 2 2 minus 2 minus root 2. Root 2 take common everywhere. So 2 we can write root 2 into root 2. So we can say root 2 is it will be root 2 into root 2. Root 2 into root 2 equals to 2. Minus again root 2. This is equals to 2. So root 2 take common everywhere. So here it will be 1. 1 into root 2, and root 2 is common. So it will become root 2 minus 1. So root 2 cancel again. So it will become 1 by root 2 minus 1. This is the ratio. Simplest ratio. 1 divided by 1. 1 divided by 1 divided by root 2 minus 1. So root 1 equals to also root, here it is written root 1. So second time also when you do for 3 also, na 3 meter. So 3 meter also it will be 3 meter will be what? Total 3 minus up to 2 whatever the time. So T3 minus T2 will be the this root 3 minus root 2. And first we calculated T1 by T2, T1 by T2, root 2 equals to 1 only. So 1 by root 2 minus root 1. And it is root 1. You can write 1 equals to root 1. No problem. So which option came? Thus they have written it as root 1 by root 2 minus root 1. Root 1 already we know 1 only. Root 1 already we know 1 only. So simply you write 1 by root 2 minus 1, or you write root 1 by root 2 minus 1. Both things are same because root 1 equals to 1 only. Okay. So option 2 is the correct. 37 is done. Now we'll solve question number 38. So what is 38? The body is dropped from a height 122.5 meter. Okay, suppose something is dropped from a height. How much height? It is so much. 122.5 meter. This is our height. If it is stopped after 3 seconds. So after this is our ground. So after suppose when it is going downward, and suppose here time was 3 seconds. Our time was 3 seconds. Then here someone stopped it. Here it is stopped. So and again release. After stopping again release. So after stopping further release, then time of descent, then further time of descent. So when it is stopped here after time 3, then we have to tell what is this time? What is this time? How after how much time it will go to ground? So can we calculate? Yes. First, we will calculate how much distance it covers. Total distance cover, total was 120. So in starting 3 seconds, how much distance it will cover? We will subtract from this. Then we will calculate how much this is distance. Once we got this, what is this distance? We can calculate how much time it will take to go from here to here. Here also our u will become 0 because it will come. They stopped here, so velocity will become 0. So first we'll calculate how much is this distance. Okay, make it better. Huh. Now, first we will, what is this? Suppose this is the height in 3 seconds. First we calculate this, and this is the height in time t which we have to calculate, and total height is 122.5 meter. So first we calculate what is this height in 3 seconds, in time 3 seconds. So u equals to 0. We know formula how to calculate height. Height is what? Distance only. So s equals to ut plus half at square. We have to calculate height. Initial velocity 0, 0 into time 3 seconds, 0 plus half into, we have to take g equals to 9.8. Write g only, no problem. Time equals to 3 seconds, 3 second square. So height will be equals to uh, g by 2 into 9, 3 square 9. So 9 by 2 equals to 4.5. So 9 by 2 equals to 4.5 into g. 9.8 into 9 by 2. Near 9 by 2, 4.5. 4.5. This is the height. So, okay, multiply it. 9.8 into 4.5. What is the multiplication value will come? 0, 49, 39, 44, 2, 44.10. Huh? So we got 44.10. This is equals to 44.10. So after 3 seconds, it will come up to how much distance? H equals to 44.10 meter. Okay, this much it will come. After that, here what they done? Here after 44.10, they what done? They done stop it. Stop means again velocity becomes 0. Stop means again velocity will become 0. So again they will release from here. Again they will release from here. When they release from here, how much time it will take to go up to the ground? So we know 44.4 came. So what is this height? This height is equals to what? Total was 120, 122.5, and above side 44 point, we calculate 44.1. So minus 44.1 equals to h. So h equals to 5 minus 1, 4, and 12 minus 4, 8, and 11 minus 4, 7. So 78. So below side 78.4, above side 44.4, total 122.5. So now tell me how much time it will take to cover this height. So again we apply same formula. But height is what? Again formula is height equals to ut plus half gt square. Height is what? 78.4. Ut again 0 because here stop, so release 0. 78. So again our we have half into g is 9.8 into what? Time square. Into what? Time square. So 78.4 into 2, 8, and okay, 15.56.8 divided by 9.8, again is square root equals to t. So it will equals to 150, 1568 divided by 9.8. Okay, so this point cancel, so it will become a square root of 1568 divided by 98. So yeah, 1568 divided by 98, 98 and then 98. Okay, uh, uh, 5 588 588. So if we do 6 time multiply, 58. So it will be cross. So we got 16. When you divide, you will get equals to square root of 16. So time equals to square root of 16 equals to 4. Square root of 16 equals to 4. So time equals to 4 second. Time equals to 4 second means option number 3. Now we have to solve question number 39 also. We will solve fast. A freely falling body travels how much percent of total distance in 50 seconds? If something is suppose falling, uh, if something is falling, so suppose total time it fall 5 seconds. Total time equals to 5 second. 5 second. So first suppose here it falls 1 second, here 2 second, 3 second, 4 second. This is the fourth second, this is the fifth second. So it is saying out of total distance, how much distance it will travel, how much percent will be in the fifth second. So suppose fifth second height will be h5, and total height will be what? H. Total height will be h. So we have to take percent of h5. H5 of h into 100. This is the percent ratio we have to calculate. So total height. So we have one formula to calculate in the nth second. So h5 equals to u. U is what? 0. 0 plus. No. What is that formula? H5 equals to u plus a. A is what? G into n minus 1 by 2. N is what? Fifth second minus 1 by 2. So h5 will be equals to 0. U is 0 plus 5. 5 into 2. 10 minus 9. 9g by 9g by 2. So it will be equals to 9g by 2. H5 we got 9g by 2. Okay. And this we have to calculate h5 divided by h. How much height it will cover in the 2 second? Now second case, total height h, total height h equals to total height ut plus half at square. Ut is what? 0. Again half g into time 5 second. Total how much distance it will cover in the 5 second? 5 time 5 second. So 5 square 25. So it will become 25g by 2. This is the total height. Now we have to take percent. What was our percent? Percent h5 by h. H5 is what? H5 9g. Percent. We have to calculate percent. So we have to calculate h5 by h. H5 is 9g by 2 total divided by h. H is what? 25g by 2 into 100. Percent you know how to calculate. 2 to calculate 2 to cancel. G cancel. So it will become 9 by 25 into 100. 25 on the 25. 25 for the 100. 9 to 4, 36%. 36% it will cover out of total height. Whatever it will cover in the 5 second, out of that height, 36% of that height it will cover in the last fifth second. Understand? So 36 written. So question number 40 and 41. I will solve question number 40. 41 homework. If the distance traveled by the freely falling object in the last second of its journey is equal to the distance traveled in the first 2 seconds, then the time of descent of the body. Time of descent means falling time. If the distance traveled by the body in the last second of its journey is equal to the distance traveled in the first 2 seconds. It is saying, suppose something is falling, okay? So in the first 2 second time equal to first 2 second, whatever the distance s2 we can say in the 2 second. Whatever the distance it will cover in the first 2 second will be equal to the distance traveled in the last second. So last second will be what? Suppose this is the uh, total time is t. Okay, so total time is t. Then the tth second distance will be equals to 2. So tth second distance is what? St means nth second. Sn formula again. So total distance covered in the 2 second is what? Total distance in 2 second. So what is there? So ah, so total distance covered in the starting 2 second. So S2 equals to what? Ut plus half at square ut 0. So half at square acceleration g time 2 second. So S2 equals to 2 is 2 square 4. 4 by 2 2g 2g. This S2 distance is 2g. How much distance it will cover in the nth second? Nth second equals to Sn equals to u is 0 only. U is 0 plus uh, a into n minus 1 by 2. A is what? G into n time, suppose t minus total time t. So t minus 1 by 2. Okay, in the nth second. So then this is equals, they both are equal. It is saying distance covered in the starting 2 second will be equals to distance covered in the nth second. So we can write 2g, this distance s2 equals to g into total time, whatever the time it will take, suppose time t minus 1 by 2. G cancel. So 2 equals to t minus 1 by 2. 1 by 2 will go that side. 2 plus 1 by 2 equals to t. So 2, 4, 2.5. 2.5 equals to time t. What is the question? Time of descent of the body. How much time it will take to come downward? So that is time of descent equals to 2.5. We calculated time t equals to 2.5. 2 plus half equals to 2.5. So time of descent 2.5. Now 41 question, how you will solve? A ball dropped from homework question. Question number 41, homework. How you will solve? A ball dropped on the floor from the height 10 meter. This is the floor. This is the height. Height equals to 10 meter. Rebound to height of 2. When it will fall, it will again go to 2.5 meter. If the ball is in the contact with the floor for 0.2 second, ball with the contact with the floor for how much time? 0.02 second. Its average acceleration during the contact. Average acceleration equals to the force, and force equals to what? Change in momentum. So first you have to, what you have to do? First find the velocity here in the last point, whatever the velocity here. Okay, and then and then and then it will go with, then you have to, what you have to say? First you got here, see what is happening here. See, this is suppose floor. Okay, this is the floor. When ball will come from here, suppose it will have some velocity toward downward. Suppose this was v1, v1, and again it will, wall will apply, uh, wall is floor. Floor will apply for force on the ball, so ball will go here. So suppose here velocity was v2. So but it is going up to height how much? How much height is it going? 2.5 meter. Here velocity will become 0. That's why it is going up to, so here v equals to 0. So you can calculate this how v equals to u, v equals to u plus a, you apply that formula, v square minus u square equals to 2 into g into h. You know here h, you know here g, you know 2 also. Here velocity become v equals to become 0. Here your initial velocity when it is going, it is v2, v2. Now you can calculate v2. Once you got v2 and you have v1, then what is the formula force? Formula force will be force equals to change in momentum by time, and force equals to mass into acceleration. Here mass into v final minus v initial divided by time, mass cancel. So acceleration equals to, we have to find acceleration only, so acceleration equals to v final. V final is this and v initial is this. Its direction is negative, its direction is positive. So what you can do, v final whatever you get here minus whatever the velocity you will calculate when it comes downward. You can calculate what is the velocity at this point when something will fall at the 10 meter. Again apply the same formula, v square minus v square equals to 2as. So this velocity, this velocity minus of, so they both will get add, huh? So this is suppose positive, so it is positive. This suppose negative, so minus of minus v, whatever the velocity you have taken here v1, divided by time 0.02 second. Then that will be your acceleration. Change in momentum by time. Mass will get cancelled. So acceleration will be what? Whatever the velocity here at this point. So acceleration will be what? At the time of going, what was the velocity? At the time of coming, what was the velocity? Suppose this is v final, suppose this is v initial. So v final minus v initial by time will be your average acceleration. Now you have to try to calculate. Okay, thanks.